In the previous video, we have seen how to create the homogeneous graph using DGL. Okay, we have created a sample graph with 5 nodes and 8 edges using the DGL graph method. Okay, now let's see some more functionalities on these DGL graphs. Okay, so let's check for the nodes and edges. So we already have the graph stored in this graph object. So let's see the nodes on this graph. Okay, we can just call graph.nodes. So it will give you a tensor which is ranging from 0 to 4. If you see this graph, how many nodes do we have? We have 5 different nodes whose indices are starting from 0. Okay, so the node IDs are ranging from 0 to 4. Okay, so whenever we call graph.nodes, it will give us a tensor of node IDs. Okay, similarly, let's try to call graph.edges. Okay, so graph.edges returns a tuple of source node tensors and destination node tensors. Okay, it is the same tuple that we have passed as an input to the DGL graph. If you remember in the previous video, we have passed a tuple as an input to the DGL graph. So what is this tuple? So this tuple contains two tensors. One tensor is of source node IDs, the other tensor is of destination node IDs. So whenever we call graph.edges, it will again return the same as output. It will return two tensors, a tuple of tensors. Okay, the first tensor is the source node IDs, the second tensor is the destination node IDs. But let's say along with the source node IDs and destination node IDs, let's say I also wanted to see the edge IDs. For that, we just need to mention this parameter as form is equal to all. So this will return a triple. Okay, so you can see the first tensor in this triple refers to the source node IDs. The second tensor in this triple refers to the destination node IDs. The third tensor in this triple refers to the edge IDs. Okay, as we know in this graph we have 8 different edges. So we are explicitly not passing the edge IDs, but the DGL.graph method will internally assign the edge IDs. Okay, so again similar to nodes, the edge IDs are also ranging from 0 to total number of edges minus 1, that is 0 to 7. Okay, and the order of edges will be equivalent to the order of source node and destination node IDs that we have passed. So for this specific edge, that is from 0 to 1, DGL assigns the edge ID as 0. From 0 to 2, it will assign the edge ID as 1 and so on. So whatever order that we have defined the edges here, on the same order, DGL assigns the edge IDs, okay, which are again ranging from 0 to max minus 1. Okay, and this is the directed graph, right? So we have created the directed graph using DGL.graph method. But in one of our previous videos, we have seen the undirected graph, which is also known as the bidirected graph. So what if we don't have edges here? What if we don't have edges here? So let's try to create the undirected graph using the same set of nodes and edges. Okay, so I'll just copy the same code here. Okay, so I'll just paste it here, and instead of calling this as graph, I'll call this as undirected graph. Okay, but here, along with whatever edges that we have, we also need to have the reverse edges, right? So this edge can be represented as 0 to 1, but if we don't have the direction, then we also need to represent this edge as 1 to 0, right? It's like bidirectional or undirectional. Okay, so what I'll do here is that, so I'll take all the source node IDs and also I'll add all the destination node IDs here. Okay, I'll just add everything here, and I'll just copy all these things here. So what I'm trying to do here is that I'm just trying to add the reverse edges. Okay, so we have 0 to 1, so now I'm trying to add 1 to 0. Okay, we have 0 to 2, I'm trying to add 2 to 0. We have 0 to 4, I'm adding 4 to 0. Okay, so now let's see what it contains. I'll just print undirected graph. Okay, so now when we print this undirected graph, now you can see the total number of nodes are 5, but the total number of edges are 16. Okay, because on this graph, if we don't have the directions, then each edge is represented by two types of source and destination node pairs. one pair can be 0 comma 1, the other pair can be 1 comma 0. So as we have 8 different edges on this graph, if we make them undirected, then we need to represent them as 16 different edges. Okay, 16 different edges, but we don't need to explicitly add all these reverse edges every time. We have a internal function in DGL. So instead of manually adding these reverse edges, what I'll do here is that, so I'll write, we already have the graph, right? So we have a graph, which is the DGL graph object, which is the directed graph. So what I'll try to do is that I'll try to, you know, apply one of the functions on this graph, okay, which is the bidirected. Okay, so I think this is the function. So we need to use DGL dot bidirected, and I'll pass the graph as an input, and I'll take let's say undirected graph. I'll just call it as new, because we already have an undirected graph here. So now I'm getting a new undirected graph. Let's try to print this. Let's try to print this undirected graph new. Okay, so I'm passing the directed graph as an input to the to bidirected method in DGL. Okay, so if you can see here, it will convert the graph to a bidirectional graph. Okay, so if you pass a directional graph, it will convert that to the bidirectional graph. Internally, it just adds all these reverse edges. So if you print this undirected graph, you can see again the number of nodes are 5, the number of edges are 16. So whenever you wanted to convert a directed graph to a bidirected graph, we don't need to explicitly add the reverse edges. Instead, we can use the DGL inbuilt to bidirected method. Okay, thanks.